In this video, we will look at square numbers and find the square roots of numbers. When a natural number is multiplied by itself, the result is a square number or a perfect square. In the expression 7 squared equals 49, 49 is a perfect square. This terminology comes from a common formula for finding the area of a square, a equals x squared, where a represents the area and x is the length of one side. When we square 3, we write 3 squared equals 3 times 3 equals 9. So we say 9 is the square of 3. I will note as an aside that we do not actually have to write out the 3 times 3 part of this expression. We are asked now to find the square in this example. First, we want to square 2. 2 squared is 2 times 2, which we should know is 4. 7 squared is 7 times 7, which we saw on the previous page is 49. 3.2 squared is a little more complicated. That's still 3.2 times 3.2, but we may not know off the top of our heads how to solve this problem. I will tell you now that you can use your calculators to answer questions like this if you need to. However, I know that this is 10.24. The inverse operation of squaring is taking the square root of a number. The principal square root of a perfect square is the number that was multiplied by itself to equal that perfect square. The principal square root of 9 is 3 because 3 squared equals 9. The radical sign, this guy right here, indicates that we are taking the square root of the number within. The number under the radical sign, or under the bar, which is this part of the square of the radical sign, is called the radicand. The entire expression is called a radical expression. So if we have the square root of 25 equals 5, we have the radical sign, the bar, the radicand is 25, and 5 is the principal square root. To find the square root of a perfect square by estimation, first select a trial estimate of the square root, then square the estimate. If the square of the estimate is less than the perfect square, adjust the estimate upward. If it is greater, adjust downward. Then repeat steps 2 and 3 until you find the square root. Now, in the book, they give the first estimate for the square root of 256 as 15. And I have a problem with this because any odd number multiplied by another odd number is odd, but 256 is clearly even. So instead of choosing 15, I'm going to choose 14. 14 squared is 196. That's too high. So let's pick something bigger, say 18. 18 squared is, let's see, I don't remember off the top of my head. So I'm going to have to grab a calculator. I've got one here somewhere. There we go. I could multiply it out by hand, but why bother when there are calculators in this world? 18 times 18 is 324. That's too high. We're like the 3 bears here. So I picked the number right in the middle, which is 16, and 16 squared is 256. Now we want to find the square root of 12 to the nearest tenth. 12 is not a perfect square, so we aren't going to find a whole number or a natural number that will square to give us 12, but we can find something close. I know that 3 squared is 9 and 4 squared is 16. So I'm going to pick something between 3 and 4 and see how close that brings me. So let's say I pick the number 3.3 and square that. 3.3 squared, according to my calculator, is 10.89. We're going to have to go up a little bit. So I'll try 3.5. That gives me 12.25. So now I'm going to try 3.4 squared, just to see if it's closer to 12 than 3.5 squared. That's 11.56, which is further from 12 than 3.5 squared is. This is 0.44 off. This is only 0.25 off. So the closest number to the square root of 12 to the nearest 10th is 3.5. Finally, I'll just mention something about perfect squares less than 100. The only perfect squares from 1 to 100 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, which are the squares of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, respectively.